Good evening. Today's lecture is the first in the series of lectures regarding the components of partial denture. As you can see in this slide, it shows an example on a removable partial denture where the components are visible on the abutment teeth and on the palate for a maxillary arch. Now, generally, any removable partial denture should fulfill certain requirements to be successful. First of all, it has to have proper support, which is resistance to occlusal or vertical seating forces towards the teeth or tissues. It has to have good stability, which is resistance to horizontal forces, and retention, which is the resistance to vertical dislodging forces away from teeth or tissues. So the components of the removable partial denture should provide these three requirements. Some of them might provide one or two of these requirements actually. Now, the components in general, first of all, we have the major connector, which in addition to connecting between the components on one side to the other side, it provides support. The minor connectors, in addition to the connection between the different components with the major connector, they also provide stability. And we also have the rests, which are there to provide mainly support. And we have the direct retainers that provide retention, the indirect retainers that provide retention, denture base provides support, and reciprocal or stabilizing components also provide stability to the dentures. In this slide we can see the different components اللي هم طبعا عندنا the major connector here. It's an anterior posterior palatal strap. We have minor connectors and direct retainers are the clasps, eye bars on both sides, and this is an occlusal rest and an indirect retainer. These are and not to forget the guiding plates, which are contacting the guiding planes proximally. These are the different components of the partial denture. Now, today's lecture is about guiding planes and guiding plates and rests and rest seats. Guiding planes. These are two or more parallel axial surfaces on abutment teeth which can be used to limit the path of insertion and improve the stability of removable prostheses. They might occur naturally, but in most of the cases you need to prepare them. So they are parallel axial surfaces. They are not just proximal, they can be on the palatal and proximal surfaces as well, and the main function is to improve the stability of removable prostheses by limiting the path of insertion and removal to a single path of insertion and removal. In this slide, you can see that after surveying and choosing the most appropriate tilt, you choose the appropriate pair, and then you prepare guiding planes on all abutment teeth. On the abutment teeth, and they all have to be prepared parallel to each other and parallel to the most appropriate tilt that you chose. Now in this example, because it's a bounded saddle between two posterior teeth, they are on proximal surfaces on the mesial and the distal, but you will see that guiding planes can actually be prepared on lingual surfaces, on palatal surfaces, in addition to proximal surfaces. Now, the surface of the tooth along which the proximal plate slide is the guiding plane. The guiding plane and the guiding plates should be in intimate contact. The intimate contact between the guiding plane, which is the prepared surface of the tooth, and the guiding plate, which is the component of the partial denture that comes in contact with the guiding plane, it provides, in addition to limiting the path of insertion and removal, it provides retention via the friction between the guiding planes and guiding plates. Usually, the occlusal gingival height of the guiding planes is around 2 to 3 millimeters parallel to the path of insertion and removal. Now, guiding planes, there are different types of guiding planes. There are guiding planes on abutment T's supporting two supported RPDs, yani bounded saddles, mainly class 3s and class 4s. Guiding planes on abutment T supporting distal extension bases. They are slightly different. هلا بنحكي كيف. And guiding planes prepared on the lingual surfaces of abutment teeth and on anterior teeth. Guiding planes on anterior teeth. Anterior. Now, this is an example of two guiding planes prepared on abutment teeth in a bounded saddle. You can see that having the guiding planes will actually facilitate the insertion and removal of the denture in a single path of insertion and removal. This will make the insertion and removal easier for the patient and will also limit the movement, the horizontal movement, and improve the stability of the denture, which is the main function of the guiding planes. Now, for distal extension bases, guiding planes are prepared to be shorter than the ones for abutment teeth supporting bounded saddles. They are around 1.5 to 2 millimeters as opposed to 2 to 3 for the bounded saddles. Now, why do we make them shorter for distal extension bases? The reason is in this way we make it easier for the guiding plate to disengage the prepared guiding plane on the abutment tooth upon the stress, and disengaging will help breaking the stress around the abutment tooth. This is a technique or a principle of the stress breaking effect of on the abutment teeth. It's very important for distal extension base abutments, most distal abutments, and we will be talking about it later on. Now, guiding planes prepared on the lingual surfaces of abutment teeth. Some of the components you will be finding actually of the partial denture on the lingual surfaces, mainly on the lingual surfaces of anterior teeth. If you have a rest on the lingual surface above the cingulum, then part of the minor connector connecting between the rest and the major connector will be crossing the lingual surface of the tooth, and to make insertion and removal easy, you have to prepare a guiding plane on the lingual surface that holds that makes it easy for the minor connector to hold the rest and be seated appropriately. This is an example of this case. Now for anterior, the guiding planes prepared on abutment teeth are especially important for anterior teeth, especially important because they are important to improve the aesthetics. If you if you don't prepare guiding planes on anterior teeth and insert the denture, then you can only insert it without engaging the undercut areas, and in this case you will have very unpleasant gaps between the denture and the abutment teeth, which is certainly not appropriate for anterior teeth. While in the second case, if you prepare guiding planes, you can insert the denture to actually to be extended in an undercut area relative to the common path of displacement, but non-undercut area relative to the chosen path of insertion and removal, and this way you can close the gaps between the anterior teeth and the denture base. Now the preparation of the guiding planes, you use usually طبعا باللاب you used low speed handpieces, straight handpieces on the acrylic teeth, but for cutting enamel you always need high speed handpiece, and for proper cutting you need diamond bears. You need fissure or straight fissure bears, diamond bears. You can use chamfer or shoulder bears for the preparation at high speed. And the preparation, to do the preparation, you need to hold the bear and the handpiece parallel to the score lines that you draw at the sides of the cast and transfer it on the abutment teeth, cutting in a few strokes anterior posteriorly, and focusing mainly on the proximal surface towards the lingual, not showing on the labial surface as much as possible, because the show of metal on the labial surface will not be acceptable, especially on premolars. So you hold the bear parallel to the tilt and you do few strokes on the proximal surface. You don't need to cut it. You don't need to cut too much, and you don't need to have a finish line. All what you need to do is to have an area around 2 to 3 millimeters parallel to the path of insertion and removal. During the cutting, you don't cut it straight, bucco lingually. If you cut it straight, then you end up cutting too much of the tooth structure. The end result of your preparation will be an area of 2 to 3 millimeters occlusal gingivally that is parallel on all the abutment teeth, and the shape will be looking like a cylinder. It is 2 to 3 millimeter occlusal of an area that is parallel or straight, 2 to 3 millimeters occlusal gingivally, but it should be following the contours of the tooth buccolingually, so that we don't end up cutting too much of the tooth structure. Generally, the functions of the guiding planes, in addition to making insertion and removal easier by limiting the path of insertion to single path of insertion and removal, which also provides stability for the prosthesis against horizontal forces. It also reduces the block out area and improves the appearance. And also they contribute to indirect retention and frictional retention, and they prevent clasp deformation, and they can also provide reciprocation. Let's discuss each of these functions in details. Now, if the denture can be inserted and removed in one direction, then it cannot be moved horizontally easy, and the resistance to horizontal forces, as we know, is called stability. So limiting the path of insertion and removal increases the stability and makes the insertion and removal easier. Now, regarding the reciprocation, now what do we mean by reciprocation? لما نحكي طبعا عن direct retainers رح نحكي in more details about this, but all what you have to know now that the retentive tip of the direct retainer or the clasp is the only component that goes below the survey line on the tooth. Now, as it moves over the bulge downwards or upwards, it gets flexed. Now, the flexion of the retentive tip on the buccal surface here will cause the tooth, will exert a force on the tooth towards the other direction, towards the lingual. Now, if you do not have a component on the other side that prevents or counters or reciprocates this movement, the tooth will move to the other direction, and this will result in an orthodontic movement of the tooth to the other direction because of the clasp. Then you have to have a reciprocal component on the other side of the retentive tip that counteracts the effect of the force it exerts during insertion and removal, or while it moves up and down the maximum bulge of the tooth. And for this, you have to provide a reciprocal component. This can be a reciprocal arm, reciprocal plate, different components. Whatever the component is, it should be in contact with the tooth all along the way while the retentive tip is moving down and up the survey line. To make sure the reciprocal component is in contact with the tooth during the movement of the retentive tip up and down the survey line, you have to prepare a reciprocal a guiding plane on the other side, which is here on the palatal surface. Again, it's around 2 to 3 millimeters, and this makes sure that the reciprocal component is always in action. Prevention of clasp deformation. Now, the clasp, to locate the clasp tip in a certain place, there are certain measurements that you do. You measure the depth of the undercuts, and you choose the most appropriate undercut, and you choose the most appropriate material for the clasp according to the depth of the undercut in that area. So the clasp should flex to a certain limit while it moves up or down the survey line. Now, if you have a single path of insertion and removal, this flexion, according to your calculations and the measurements, can be done in only certain limit, and the limit the clasp can actually withstand without fracture or permanent deformation. If it can move in different directions, then it can be flexed beyond the limits of the material, and this will cause the material to deteriorate and have permanent deformation. Permanent deformation means that it will be exerting harmful forces on the teeth, and this will affect the periodontal condition and the bone support of the teeth negatively, and it might cause them to move as well to orthodontically move, which is not the right thing to do, and also the clasp will not be providing the appropriate retention that it is supposed to provide. So we have to have proper guiding plane to limit the path of insertion and removal, to have the clasp function and provide the major function, which is the retention, and prevents its deformation. Improved appearance. Again, when you prepare guiding, this is particularly important for anterior saddles. When you prepare the guiding planes according to the chosen path of insertion and removal, and for the anterior saddle, it's mostly posterior. You can extend the peripheries of the dentures, in this case, to areas that are, if you look here, the acrylic on the next to the lateral incisor is an undercut relative to the common path of insertion and removal, but it is not an undercut if you consider the posterior tilt. It can be removed and inserted easily with a posterior tilt, but it cannot be moved along the common path of displacement, because this part of the acrylic here is in an undercut area and preventing the displacement along the common path of displacement. And this way you can actually cover the unsightly gaps that that are actually that can result if you have the denture with no guiding planes prepared. Because if you do not prepare guiding planes, you can only insert and remove along the common path of displacement, and you cannot extend the acrylic to cover the gaps, and it will not be acceptable aesthetically. Now, let's move to rests and rest seats. The rest is a rigid extension of a removable partial denture which contacts a remaining tooth or teeth to dissipate vertical or horizontal forces. The rest is the part of the partial denture, and the rest seat is the portion of the natural tooth or the restoration prepared to receive an occlusal, incisal, lingual, internal, or semi-precision rest. Whatever the rest is, the rest seat is the preparation on the tooth or the restoration that is prepared to receive the rest component from the partial denture. Classification of the rests. We have two classifications. There is a classification based on the relation of the rest to the direct and or indirect retainers, and also the classification based on the position of the rest on the abutment. Regarding the first classification, uh, there are primary rests. These are placed along with the clasp assembly. The clasp assembly اللي راح تحكي عنه بالlecture الجاي هو is composed of the retentive arm, reciprocal arm, or components, and part of the body, and part of it is the rest. This rest that is a component within the clasp assembly and it is placed on a primary abutment, is a primary rest, while the other types of rests is a secondary or auxiliary rest. This is provided alone, and it's provided additionally, not on one of the primary abutments. It's an auxiliary rest that is provided for the purpose of providing indirect retention. So it's a rest, but it's actually an indirect retainer. برضو رح نحكي عنها بعدين. The other classification is based on the position of the rest on the abutment. Can be an occlusal rest on the posterior teeth, basically cingulum rest on the anterior teeth, incisor rest, and there is the interproximal occlusal rest. the whatever the type of the wrist is, there are certain functions that can be provided by occlusal wrists. The first and most important function is to transmit the forces along the long axis of the tooth, which is providing support to the prosthesis. It secures the clasp in a proper position, assists in the distribution of occlusal load, prevent extrusion of abutment, prevent food trapping between abutment and clasp, provide resistance to lateral forces, sometimes can contribute to indirect retention, and used to close small spaces where a tooth cannot be placed. Finally, it can help to build up an occlusal plane of a tilted tooth. Let's go through these functions in more details. Now, transmit stresses along the long axis of the tooth. This is an example of an occlusal wrist. Usually it is prepared on a posterior tooth, a premolar or a molar. Now it has certain configuration رح نحكي عنه بعد شوي that allows it to transmit the occlusal forces to the long axis of the tooth. Now the configuration is about this angle اللي هو the angle between the floor of the receipt and the prepared guiding plane. This angle should be less than 90 degrees. Now this angle should be less than 90 degrees because in this way, when occlusal forces contact the tooth, the angulation will transmit the forces to the center of the tooth, to the long axis of the tooth. Because why do we need this? Because the wrist itself is not placed on the center of the tooth, it's placed on mesial or distal part of the tooth. So to be able to transmit the forces to the center of the tooth and to the long axis of the tooth, it has to have this angulation. Now, as it moves through the long axis of the tooth to the periodontal ligament, it transmits the forces to the underlying bones, and the bone can absorb the forces. And this is what we call support. So this is the first function of the wrist. It secures the clasp in a proper position. Now, if there is no wrist within the clasp assembly, then whenever the occlusal forces are applied with the abutment tooth, the clasp will move up and down, and this will prevent the clasp from providing the basic function, which is the retention. So by having a rest, the rest will prevent sinking or movement of the RPD gingivally or towards the tooth, and this will secure the clasp in its position and prevents its deformation, and also allows it to provide its basic function. It assists in the distribution of occlusal loads. Now, when you design the partial denture, you distribute distribute the load on the teeth, the remaining teeth, and the residual ridges. So by having the rests, it assists in the distribution of this occlusal load more evenly and in more a realistic way. It provides resistance to lateral forces. Now you can see this is an occlusal rest in a cross-sectional view. You can see that it is saucer. Usually the rest seat is like a socket, and the rest is like a bowl. So our saucer. Now with rounded angles, no sharp angles. When you when the horizontal forces are applied to the rest, it actually moves as the ball moves inside the socket, and this will actually dissipate the horizontal forces instead of transmitting the forces to the long axis of the tooth, which is a very good thing because horizontal forces are very harmful to the tooth. And it contributes to indirect retention. We will be talking about indirect retention in more details in the next lecture because we will be talking about retention and retainers. But all what you need to do is that to know for this lecture and know basically for distal extensions prosthesis, or when you have tooth tissue supported prosthesis, there is an element or a possible movement for the prosthesis because of not having more a distal abutment for the distal extension prosthesis to provide retention for the saddle. Then there is a possible movement upon the gravity, sticky food, or whatever, or the movement of the muscles, that this movement tries to lift or drop the distal extension away from the tissues. Now, if you provide a component anteriorly via the rest on and the more on an anterior tooth, then that provides support. It prevents sinking of the most anterior part of the um, saddle, and if it prevents sinking of the anterior part of the denture, it will indirectly prevent the dropping or lifting of the distal extension. So it's basically a retainer because it prevents movement of the distal extension away from the tissues, but it does it indirectly by providing support on a tooth anterior للفulcrum of rotation. If this rest prevents sinking of the anterior part of the denture, then it prevents lifting of the distal extension, and that's why it's an indirect retainer and it's an auxiliary rest. Actually, you provide it additionally to provide indirect retention for distal extensions or for dual support prosthesis, and they come in the form of rests. طبعا في other types of indirect retainers, but the rests are the most efficient indirect retainers. This is the axis of rotation. Now, the axis of rotation happens when forces try to move the distal extension away from the tissues. Then the denture rotates and the anterior part of the denture sinks anteriorly. So you provide a rest anteriorly to prevent the sinking anteriorly, which indirectly prevents the lifting of the distal extension, and this is the function of indirect retainer. To close small spaces where a tooth cannot be placed, sometimes if there is a gap between the remaining teeth and you cannot place a tooth in it, and also you cannot leave it unclosed, then you can close it with a rest, with an extension of the rest. Also, you can build up an occlusal plane of a tilted tooth with an extension of the rest on the occlusal surface. Now, let's see how occlusal rests are prepared. Occlusal rest teeth are prepared. Now, occlusal rest is a rigid extension of a partial denture that contacts the occlusal surface of the tooth. So it's basically on a premolar or molar tooth. These are the dimensions. إذا أخذنا top of occlusal view, it goes half of the distance buccolingually and 1/3 of a distance mesodistally, 1/3 of a premolar, and 1/4 of a molar, because the molar is bigger basically. And it's a rounded triangle with the base towards the marginal ridge and the apex towards the center of the tooth. If you get a proximal view, again, it looks like a saucer, زي الصحن, in a socket with rounded angles. And from mesodistal view, شفنا قبل شوي, it looks like a spoon actually. On mesial or distal part of the tooth, it has the maximum depth around around the center, in the part that goes towards the center of the tooth, and the shallower part on the marginal ridge. It's around 1 to 1.5 millimeter in depth. The anteproximal occlusal rests are actually similar to the mesial or distal أو occlusal rests يعني in general, but they have additionally you lower the embragers buccally and lingually for the direct retainer retentive arms and reciprocal arms to emerge on the buccal and lingual surfaces on the abutment teeth. This is basically for a type of a direct retainer called double acre. So you prepare the rest normally, and then you open the embragers a little bit for the retentive arm and reciprocal arms of the direct retainers to emerge of the buccal and lingual surfaces respectively. Now, why do we have to prepare rest seats? They have to be prepared to produce a favorable tooth surface for support. If you look at the first picture, now in the picture in the scenario number 1, if you do not have um, a rest seat prepared to to accommodate the rest, then as occlusal forces are applied on the tooth, the rest will just slide away, and instead of transmitting the forces to the long axis of the tooth, they will just slide and exert harmful forces on the teeth, and this will be traumatic to the abutment teeth. While if you prepare the rest seat to accommodate the rest, when occlusal forces come in contact, they are transmitted through the rest and the rest seat towards the long axis of the tooth. Also, you have to prepare the rest seat to prevent interference with occlusion. As you see here in number 2, if you don't have the rest in its rest seat, then it will be high in occlusion. It will have a deflective contact, while if you reduce our prepared rest seat, it will not interfere with the normal occlusion. Finally, you have to prepare rest seats to reduce the prominence of the rest. If the rest is too prominent beyond the contours or the natural contours of the tooth, then the patient will object on it because it will be annoying. On posterior teeth, again, these are the dimensions of the rest seat. It's a rounded triangle with the base towards the marginal ridge and apex towards the center of the tooth, around 1 to 1.5 millimeters in depth. And again, the angle between the floor of the rest seat with the prepared lingual plane should be less than 90 degrees to assist in the transmission of the forces to the long axis of the tooth. You prepare it using the appropriate high-speed round diamond bear with appropriate dimension. You shouldn't be using a bear of that is too small or too big. Too small, you will end up losing the right dimensions of the depth of the rest, and too big, well, you will be overcutting. So around 1 millimeter in diameter is the most appropriate. For anterior rests, you can either have cingulum or incisor rests. Okay, now the cingulum rests or the lingual rests, they can be inverted V, cingulum ledge, cingulum ball, and incisor rests it can be a hook or a ledge. راح تاخدوا بالله بالledge بس يعني مش موجودة هنا بالpresentation. It's not very common. Inverted V, basically prepared on maxillary canines, sometimes on mandibular canines, rarely on incisors. It needs a prominent cingulum to be prepared عليها. So again, mainly used in maxillary canines, and sometimes if the cingulum is not prominent in maxillary canine, you end up it is not recommended to be used. You end up using a cingulum ledge. Now it's around 2.5 to 3 millimeters mesodistally, and it looks like an inverted V but with rounded triangles, actually rounded angles. It looks like a crescent. All right, so 2.5 to 3 millimeters mesodistally. You don't break the marginal ridges of the tooth. It should be just above the cingulum. Now, from a proximal view, it has a floor that is around 1.5 millimeters deep and a wall that is around 2 millimeters high. For the preparation of the inverted V, you need, for the floor, you need to prepare it using an inverted cone-shaped diamond bear. The inverted cone, you place it on the tooth, and because of its shape, it prepares the appropriate angulation of the floor of the inverted V, which is angulated, which is inclined labio-gingivally. It slides anteriorly, and this is again to transmit the forces to the long axis, to the center of the tooth, to the long axis, and to the underlying bone. If you do not have this angulation, then you end up not transmitting the forces in the right direction and not providing the appropriate support. Now, after preparing the floor of the rest seat using the inverted cone, you use a Fisher Bear diamond bear to prepare the wall that is around 2 millimeters in its height. The idea is to have it free of undercuts. This is the most important thing. So it should be prepared parallel to the path of insertion and removal. And if you look at if you have an occlusal view of the receipt, of the prepared receipt, you should be able to locate the floor with no undercut area in the wall above it. Otherwise, the seating of the metal will not be possible. Now the ledge, cingulum ledge is prepared on whenever, of course, you cannot use the inverted V. If you have a canine or incisors that do not have very prominent cingulum, it is prepared on one of the sides of the tooth. It's either mesial or distal, so it's you should be breaking the marginal ridge of the tooth, and then you go crossing the midline slightly to the other side to have more support from the tooth. The floor is prepared with the same inclination of the inverted V. It should be inclined labiogingivally, and the wall should be prepared also using Fisher Bear to eliminate any undercut. So again, this is the ledge, mesial or distal ledge. Okay. Cingulum bowl is rarely used. It looks like a bowl and it goes on one of the sides of the cingulum, mesial or distal, and you prepare it using a round bear, and then again you have to make sure that the wall above it is free of undercuts, so you can do some flaring in the wall above it. It's very hard not to have undercut in this type of rests, and also since it is very small, the amount of support provided is actually minimal, so it's not one of the commonly used rests. Now, all cingulum rests and rest seats are only indicated if cingulum is prominent and if the patient practices good oral hygiene and has low caries index. Now, if these are not possible, then your last option should be incisor. طبعا it's the last because um, not only it's aesthetically not acceptable because it's on the incisal edge, but also because of the position of the wrist on the incisal edge away from the center of the tooth. The amount of support provided is actually inferior to cingulum wrists. So whenever you can, use cingulum wrists, even if you have to build up a tooth structure or use adhesive restorations with prepared rests on the teeth. Now, incisal hook from a labial view, it's around 2.5 millimeter mesodistally, 1.5 millimeters deep. You prepare it using diamond Fisher Bear to so that you do not have undercuts in your final preparation. This is how it looks like. It is indicated mainly for lower incisor teeth, definitely not on maxillary incisors. It looks like a hook, and that's why it's called incisal hook. Now, if you look at it, uh, now from the lingual view, it has to have a funnel shaped preparation on the lingual side of the tooth to accommodate for the minor connector that connects between the wrist and the major connector, and mostly indicated for lower canines because it can be less visible. Now the preparation looks looks concave mesodistally, but it looks convex labialingually. Through the preparation رح تتعلموا باللاب, you do bevel on the labial surface to يعني to make the hook shaped wrist to be accommodated in that area, and this is why we call it incisal hook. Again, it is only indicated whenever you cannot use cingulum wrists. If the tooth morphology does not permit other designs, and when the incisal edge is completely lost, sometimes you can do build up. The incisor wrist can restore the lost contour. Thank you very much.